Okay, we're back. Okay, let's proceed to the last example. Uh, okay, define the run function, define the main function, call, whatever. Okay, let's take a look at the endpoint that we want to call. It's exactly the one above. It's broadcast a transaction, v1 broadcast transaction, and it accepts like an encoded transaction, encoded, which is like a sign, a created and signed transactions. We'll also be importing some libraries from Go in order to sign the transaction. Okay, so this is the input encoded transaction. So broadcast transaction payload, broadcast transaction response, okay, broadcast transaction URL. Let's see if Gemini did the autocomplete well. No, always check the suggestion of Gemini, GitHub Copilot, and whatever else AI tools are you using in order to do vibe coding. Okay, so what we'll be doing here, we'll be sending like a normal transfer transaction so we'll be transferring some queues from this address to this address. Good. First, let's check the balances with our previous example. Let's return nil in order for our example to our program to compile. Here we should have some queues. Here we should have 0. Okay. Get balance. Let's see. Let's print these only the balance. Okay. Awesome. So we have 17186 and for this one we should have 0. Awesome. 0. Good. Okay, so what do we need in order to do that? To do this, we need to create the transaction. We'll be showing the transaction fields. We need to sign the transaction, and then we need to we need to encode the transaction basically for autocomplete is fine, and then send it to the broadcast transaction endpoint. Okay. Okay, so as we are in the create transaction field, we need to see which is we need to define the structure of the transaction, which we already have. We need to import some libraries from here, from our have a types library in Go, where we have our transaction struct, so we don't need to define it here. Var tx, it's a simple transfer transaction. Where is it? Where is it here? Not in assets. Transaction. Okay, so we have. Okay, good. So we have types transaction. Okay. Let's try to fill. Okay, let's create the context. Context with timeout. 5 seconds. Don't forget to defer the cancellation to avoid memory leaks. Okay, let's fill all fields. Okay, this is what we need in order to send the transaction. As it is like a simple transfer transactions, we don't need the input types. We don't need we need the input type to be 0. We need the input size to be 0 as we don't have an input. We don't need the input like at all. We need the amount, source, and destination. Okay, so in order to get source and destination, you see that they are required like 32 byte arrays. We need to define them as identities. Source ID, which is source ID is this. Source ID, destination ID, dest ID. Okay, and we have this type, which is type.identity. Okay, so this is like a types.identity, and this type will allow us to convert it to a 32 bytes array. We have a method here. Okay, and we have source ID pub key, which is to pub key is lowercase. So we have two types of identity conversions. For addresses, it's like all uppercase. For transaction IDs, as you remember, we have them all lowercase. This is also an identity. So in order to do that, we need here is lowercase to be false. This will return an error. Okay, return fnt, just wrap the error. I don't like this message. Convert source ID to pub key. Dest ID pub key. Yeah, do the same. Okay, now and let's try to send 100 queues. Input type is 0, input size is 0. Good. Here we should have a method which is called sign, which will basically sign the transaction. And what does sign the transaction does is basically getting the seed, sign the transaction, and then populate the signature field with the transaction signature. I will disclose the seed here as it's like a test seed and it doesn't have like a lot of queues. And it's this one. Okay, we can just do this here. This will probably return an error. Okay, sign in transaction, but we need to also to set the tick, the target tick. So as if you can take a look here, we will see that here we have a tick, so we need to schedule the transaction. In order to do that, we need to interrogate the status of the chain in order to get elastic and just add an offset to it. Let's do that by going to archive tree. Here we have status, channel process tick number. I think you can also do that too on yourself if you want to do it automatically. I will just use a tick number which I know for sure that it's in the future. Okay, I'll have like a target tick. I'll have an offset of, I don't know, 30 ticks, but I will replace this immediately after I am done. Okay, and here we have target tick, and only after that we can sign the transaction. Good. Now, as we have the transaction signed, we have the broadcast transaction, we have the encoded transaction, and the encoded transaction is basically, let's see, I think we also have base64, encode to base64, okay. Encoded transaction error, okay. Good. Encoded transaction, we can just put it here. We can also print the transaction ID. It's still S. Sorry, we need to do first this, as it may return an error on encoding. Getting transaction ID. Good. And now let's create the request method post body. Let's create the body. Let's copy paste what we have from here to make it quicker. Where is it? Here. Okay. The payload is basically what? The payload is exactly encode transaction, encode transaction. This is the payload. Yes. And we have the buffer here. Creating new request. Close the body to avoid memory leaks, checking for status code. Okay. Decoding response. And now let's also print the target tick here. Tick. Okay. Response, let's print everything and return nil. Okay, let's see which is the last. Good, let's run it. Fingers crossed. Okay, we have a response here. This doesn't guarantee that our transaction will be included in the block, in the tick. We have the target tick here. We have our transaction ID here. Let's also put them here, as we may want to check them. Target tick transaction. Okay. Okay. Let's check. We will be using like our last examples in order to do that. And this is a transaction ID. Let's see, did the chain already arrive at that tick? Total transactions 4, found transaction with ID. Okay, nice, so it was included. Source ID, destination ID, we can see them. They're exactly ours. Okay, amount 100, tick number. Okay, good. Money flew through. This means that the money actually flew. And in order to do a proper check, we can query the balances. Where is it? Query balance. We can query the balances of the same addresses to see if those changes. Those change. Okay, I can't remember what it was before, but I probably it was like 17186 if the other address, if the destination address is 100. It should be 100 here. Balance 100. Perfect. Okay, I think this is it. I really hope this was clear enough for everyone to understand. I'll post every piece of code. I'll post the entire Golang project for you to also have the dependencies. And yeah, I'll also be available online at the moment of the hackathon. So you will be you can ask me any questions, or if you want me to help with anything, I will be here. Okay, thanks, and enjoy the hackathon.